Let us now solve question number 20. So it says there is a pendulum and this is an elastic wall. The elastic wall makes an angle alpha with vertical and the pendulum is taken up to angle beta and then released. What is the time period they are asking? Now if this wall was not there, if you displace the pendulum by an angle beta, so that beta will be your angular amplitude, you can say, and as you release it will oscillate this way and then the time period will be 2 pi root over L by G. But here as it comes this way and it here velocity will be maximum and then as it slows down, before stopping it will hit the wall because this angle alpha is less than beta. So therefore we cannot directly say time period will be 2 pi root over L by G. Then how do we solve this problem? So there are two methods. The first method makes use of trigonometry. So here you can see, let us say this is at time 0, right? So let's say at some instant it is here. So that time it makes an angle theta with the vertical. So what function will you use for theta? It is theta is oscillating, right? So you can use sine or cos. But here at time 0 your theta is maximum, which is beta. Okay, so theta will be beta. You can't use sine, cos omega t. Correct, no? So at time 0, if you substitute 0 here, theta will be what? Beta, which is the requirement. At time 0, the angle made by the pendulum with the vertical is beta, not 0. So you can't write sine function. Okay. So what is the time taken to reach from here to here? Let us see. So when it goes from here to here, the theta becomes how much? So theta is angle measured from the vertical. So when it reaches the inclined plane, it will be on the left side of this vertical and that time theta will be in magnitude, it will be alpha, but it will be on the left side, so it will be minus alpha equal to beta cos of omega t. So this is the time taken by this pendulum to go from extreme position to the inclined plane. So that will give you cos omega t will be minus alpha by beta. So omega t will be what? Cos inverse minus alpha by beta. So that will be your omega t. So time taken will be 1 by omega cos inverse minus alpha by beta. And then since it is elastic wall, it means with whatever speed it hits, with same speed it will rebound. Which means from here to here, from here to there, the time taken will be same. So the time period of the pendulum means what? From here to here, then from here to here, right? The time period will be twice of this speed. And we are allowed to do that because the collision with the wall is elastic. So with whatever speed it hits, with same speed it rebounds. Okay. So it will be 2 omega is root over L by G, right? For a pendulum. So omega is root over, so it will be root over L by G will be G by L. So omega is root over G by L because time period is 2 pi root over L by G, right? So this 1 by omega will become root over G by L because omega is root over G by L. So it will be L by G. L by G into cos inverse of minus. Cos inverse minus alpha by beta. But we have to check whether this is there in the option or not, right? So I don't see any option which matches with this. So here you need to know one trigonometric identity which you will study in inverse function, okay? Trigonometric inverse functions. So cos inverse of some angle is equals to pi minus, okay? Minus is pi minus cos inverse of x. So if you use this trigonometric identity here, then you will get time period to be 2 times root over L by G, and cos inverse of this minus alpha by beta will be pi minus cos inverse of alpha by beta. So that would be the time period, which matches with option D. If you check, the first term is 2 pi root over L by G